Okay, so thank you, Linux Recruit and Tony, for the opportunity to be able to talk. If I let me just get that out of the way for me so I can see what I'm doing. So I want to talk a little bit about self-service, specifically of cloud resources and for Kubernetes applications. So before I do, though, a little bit about Appvia. Appvia is a product-focused company who are developing products around Kubernetes with a team focus. A bit about the developer experience. We've been working with Kubernetes for over 5 years, since the inception of the product, really. And we've been live in production since 0.9. We've seen massive reduction in costs with clients on Kubernetes, and particularly with a slant towards self-service. We're cloud native foundation members, and we've supported very large teams, many developers and many applications. So without further ado, a little bit about myself. So I'm a site reliability engineer. It's kind of the product area we work in. So I'm a developer on our product core. And I'm also a tech evangelist. So we'll see how that goes right now. I've had over 28 years, scarily, of development experience with a operations slant all throughout my career. Although 8086 assembly isn't very traditional operation these days. I now work with Golang, Kubernetes and cloud. I've worked across many sectors and in startups, and here I am in a startup again. So without further ado, self-service of cloud resources for Kubernetes applications. So today I want to cover why this isn't really that easy, a bit about the problem domain and how developers find this. What would self-service look like, what it really looks like in practice, a bit of a summary on the products in the industry scope with regards to Kubernetes and self-serving cloud resources as dependencies of applications, and a little bit about the Appvia approach and the product that we have and how that's addressing cloud resources. And a bit of a summary on what our findings are and hopefully some questions. So introduction now. Why isn't it easy? So what we've learned from doing self-service with clients is that all the products in this space are changing very rapidly. They're coming in and out of focus all the time. But the drive in the industry is around cloud infrastructure in Kubernetes, not really managed services for applications. And there's nothing really in the industry that fits self-service as we would like to have our clients experience it anyway. So the problem and developer experience. So a developer wants to be able to develop fast, locally, ideally. They're aware of, and we all use containers and Docker in order to get our cloud, our dependencies of our applications all running locally. But fundamentally, the dependencies of an application are client libraries that talk protocols to remote services, databases, or storage facilities, and they're not really cloud specifically. So when the developer needs to consume cloud, they often get a non-agile feel about this. When they try and get cloud services, they're brokered and gated through other specialist individuals, either in their organization or from a service provider. So what the developer need is around this is an application can run in Kubernetes, and it wants to consume its dependencies in cloud. Why would you need to do that? Why are managed services sometimes very important? For some teams, removing the operational overhead from the development agile team is a way of driving reliability of maintenance of that service, specifically when the crown jewels are stored. You don't really want to be charged with looking at all the operation domain that hasn't got a very good focus for the team that is developing business value if they're distracted in operation space. And there's a big question mark around simplicity in that space. So the problem, a developer develops the application on Kubernetes, and operations team, people, individuals in the team are but different people to the core business function are operating the databases. So why is that the case? The developer understands Docker and all the relevant domain, but the tooling fundamentally for creating containers and shipping them to Kubernetes is very different from the tooling that operations guys would use, typically configuration management tools for shipping to cloud providers and orchestrating that. So developer self-service. So why do we need self-service? Why do we think that's important? Well, reducing lead times by not having a separate team and not therefore needing manual intervention because of that separation of concerns and those manual processes, for example, an approval process or whatever that might be when you're talking across teams. You also, if you have a separation of concerns between the application and cloud resources for that application, there's a constraint about reliability. If you've got to communicate and coordinate the updates to your application dependencies, then you can have brittle updates. But fundamentally, we want to enable an agile process. And why agile? I mean, I guess that's been talked about, and that's a topic in itself, but fundamentally, it can reduce cost, and how it's very well known in the industry that the earlier you can detect fault and remedy it, the cheaper it is to maintain, create, and ship a product. So fundamentally, it's about cost reduction, but reliability comes with that agile process. So self-service, there's constraints that are perceived risks. So really what we're talking about here is that how do we make that perceived risk less? And I'm going to use an analogy here of when you use mobile phones, you don't consume the technicalities of how that mobile phone fits with a service provider. You don't talk directly to all the people standing up the telecoms towers and all of the details around the cost of running that. You want it packaged up and made simple. So you simplify choice, and you hope you get a whole degree of best practice by standing on the shoulders of all of those separate organizations, packaging that together and making those choices simple. You also limit the cost, hopefully. If you trust your staff, obviously in this current climate, we've all got to trust staff, but the development staff fundamentally are right in the crown jewels of your business focus, so they should be trusted, but they should see a cost reduction with the agility and reliability concerns that I was talking about. But also the perceived risk around security is reduced massively because you can enable best practice by packaging things up in the right way and providing products over brokering and conversation and coordination that's required when there are many parties involved. So developer self-service, the ideal flow would be you can peruse the service description and get all the details from your service provider, and at the point of consumption, you just need a name and a plan. So what type of service and a plan that goes with that. You provide that request to something in the industry that would be able to broker that to any cloud provider and get the concerns, the things that your application actually depend on, which would be configuration for the access of that library, the endpoints and credentials typically for a cloud service, not all the other bits. So self-service in practice, well, here we have a cloud resource in Kubernetes. That would be a great way of providing one way of self-serve, and it's something that's rapidly evolving in the industry at the moment. Here we've got an example of getting a Redis instance through Google and Amazon with their operator product direction. So this is the cloud connector, cloud config connector from Google, providing a Redis instance, and the service operator from Amazon. Very similar products, but fundamentally they look completely different. And as a developer, it's not quite clear as to what these choices mean, because they mean something to the cloud operator, but not necessarily to a developer or the application domain. It's great to be able to use familiar tools to be able to get cloud services, but not if they need brokering again by different specialist knowledge. So scaling custom resources to a developer, the reality is that there's different specifications for each and every cloud, and there's very domain-specific knowledge expected for each and every service, and there's no consistency for the developer between the cloud providers, and certainly no uplift on security, best practice, or a high-level abstraction, or isn't there? There are products, and this area has been dealt with in the past, but those products are not necessarily getting the production focus we would like these days. All of the cloud providers provide service catalogs, integrations in the guise of service brokers. So the Open Service Broker API is the standard created by Cloud Foundry for this very use case, really. And that provides custom resources. So I think it's worth digging into how that is presented to the industry. There is a concept of service broker plans, which provide a simplification for best practice consumption of services. And we really want a vetted list of those to be provided to us. So here's a concrete example of using the Service Broker API. We have the service catalog, which is the Kubernetes project, getting service plans from, in this case, the Amazon Web Services service broker. Now that publishes those plans to the service catalog if you know what you're doing and you know what those plans contain of and you know how to operate them. Then the service catalog gets them, and at the point of consumption, the developer can request a production relational database service, in this case, with a plan which gets passed as a service instance request to the service broker, which brokers it to a cloud provider, creates the instance, and provides those details back to the application for consuming. So this looks on the surface just about what we want. But if we have a little closer look at what's going on in the industry in this space. So we've just gone through the example of the Amazon Web Service service broker with lots of application services there. But the time investment, in reality, we've tried to use it in the past and we're not happy. There's a question mark around its future. Amazon have indicated that all future effort in this space is going to go into the Amazon Web Service service operator, which is too early to use at the moment. And the Amazon Service Broker does need a degree of understanding of cloud formation. You need to then construct what is really a production-ready version of those services. I mean, it's good that they've got plans. And in the service broker space, there are facilities for Azure and Google Cloud Project, but in reality, they're very much infrastructure focused in what they actually provide, and there's no recent updates. The whole Open Service Broker API ecosystem seems to be only really got a longevity or a long-term support for Cloud Foundry, and in the Kubernetes space, there seems to be a massive drive towards operators, and the Google Cloud Platform config connector has got a massive degree of effort in it, but it's got a big infrastructure focus. It's got implied configuration, so you've really got to know how you're driving it. There's configuration concerns around pod security policies, and when you actually want to use it, you haven't. You would think, because the config connector is part of the Anthos project, that it would be potentially even cross-cloud, but in reality, it's specific to Google. Crossplane is worth a mention in this space because it's got a backing of Microsoft and Alibaba Cloud, and it's also got some interesting ideals around the open application model and traits, but in reality, it's an extremely complicated piece to manage, and it's early days for that project. High hopes. You kind of want to get the best sprinkling of some of this, but not be tied into all of the brokers and the decisions right today. Terraform is alpha and experimental products, but also they're in very much the infrastructure space and certainly don't provide any self-service. So self-service for developers, unhappy developer, unfortunately. So what is the Appvia approach in this space? So we have an application, an open source application core, and we've been teasing out the details to provide this very capability for our clients. So we want a developer to be able to request a service from a plan. We don't want to have the existing infrastructure of service brokers and the service catalog because of the long life support of those projects, and they haven't been updated in the last 6 months. So we want to abstract that, provide a higher level concept, but fundamentally we do want to provide the application details in Kubernetes directly. So I'm going to do a quick demo at this point of consuming cloud resources with self-service and the use of plans, a bit about simplicity, and a bit about consuming cloud resources with a running application. So without further ado, if I click here and hope this all operates properly. So here's a view of our product. On the operations side, we can configure it and manage which services are coming from many different back-end providers of those services, regardless of the tech. We've got Amazon S3 available with plans that we provide at the high level. So there's a quick view of that. But if we now switch over to a consumer within the product for a developer's got an EKS cluster here with a couple of namespaces, and we want to consume some cloud services. Now, this demo is all going through consuming cloud services from a user interface. We have custom resource definitions behind the scenes, providing the reconciliation of these services, and obviously CI/CD capability to enable the developers to consume these under the hood. But at the point of consumption, a developer can just provide what they need for their application in their namespace, the name of a plan, and give a name for their service so they can differentiate it when it's being used and going forward. So here we've got a development instance of the plan being consumed by a developer service, but obviously some databases you may have well, not really tenant, but multi-access across different namespaces. In this case, we would have different S3 buckets, in this case, using a development plan for QA and development purposes, and maybe a completely different plan for production. So here we don't need to change any details, we just need to provide a plan name, and again, the shape of what that looks like for our application in Kubernetes. So those are being set up, and we've got one set up for the development. So now I can give a very quick view of how we want to provide extra help to the developer of how they would consume those resources in Kubernetes. We'd also want to provide a lot of extra help on those plan details and detailed configuration information around that. So here we've got a Kubernetes resource with the details of that secret, and I'm going to now go and access that Kubernetes cluster. We've got an IDP set up so that we have multi-cloud single sign-on. So we're going to use our core product to get access to that, and kubectl to get access to that context. So we can do that now. And last but not least, we're going to have a look in the development namespace in that cluster and see the secret has been provisioned. And lastly, we're going to deploy that manifest above to consume that secret in an application. So we can see that application's running as a pod in the cluster. And as a developer, I want to test out, is that working properly before going to production? I want to just port forward. I want to connect my laptop to that clustered application and get access to the application here. So we port forward from my desktop. So on localhost, I can now open a browser and connect to the application. And we can see a little demo app here where it's picked up the configuration of whatever provided that facility behind the scenes. Now, it would be great to get feedback of what you think of a user interface, what you think about CI/CD in this space, and whether you're using cloud resources in your pipelines for development. And if you would, want to be able to provide feedback, please ask some questions and I'll answer those in a tick. But in summary, the current solutions in the industry have very much an operations focus. They enable a lot of complexity, but not necessarily agility for a team. Plans are a good idea. We like the idea of providing simplicity and agility to the developers. But we also think it's important to be able to have an oversight across how those plans are being used in an organization to get audit and compliance. And that's a bit about where we're going with our product. So at this point, I'll have a look at the questions and see if there's anything I need to answer.
That's great. Thanks very much, Lewis. It's really interesting. Great. So I was going to say, where's your contact details? But they're on this slide. We can put them in the chat as well if anyone wants them. And yeah, really, really good. Thanks a lot, Lewis. So there's two questions that have come up, both actually from Alexander Stewart Krieger. First one, how would Appvia help encourage a DevOps culture where you build it, you run it, is truly in place, as opposed to a virtual wall between dev and ops?
Brilliant question. It is our reason d'etre. The reason Appvia exists is we want to be an engineering company that provides self-service and scale the way we do ops. As site reliability engineers, we think the entire landscape is commoditizing. The problem domain is moving into products and capabilities in the open source that if they were put together in the right way at the point of consumption, a developer doesn't need to know about all the operations concerns, but at least when they do consume them, they can be the concerns that pertain to an application team. So DevOps professionals embedded and being product or business focused, adding real business value and consuming commodity services, I think is the way that things go here. I've just seen your other question, Alexander. If I just answer that really quickly, your question about Terraform, it was specifically with regards to the Kubernetes providers around Terraform, but also the fact that Terraform is very much a low-level concern without a high-level abstraction, which is what we're trying to provide for developers.
Okay, perfect. There's one more question that's been put on there, but I think we may have just run out of time, so maybe you can answer to Mesbah offline.
Certainly. No worries.
So yeah, brilliant. Thanks again, Lewis. Next